This will be the fifth in a series of electrical practice problems. In this video, we will again be looking at the problem related to a series parallel circuit. Once I'm finished with the series of problems, I'll be posting them in my stand store at this web address. For this problem, I want to look at the conversion of a couple of three-point networks, specifically the delta connected and Y connected three-terminal networks, and the conversion of one to the other. For this example, we will be looking at resistances in a three-point network. However, the same process can be used for passive impedances, inductances, and or capacitance, or any combination of these. Let's first look at converting a delta connected network into a Y connected three-terminal network. Delta networks are also known as pi networks, both in reference to the Greek letters which they mimic in shape, and Y networks are also known as T networks. These are shown here. A true equivalent circuit would represent the same resistance between any two terminals as the original circuit. Looking at the delta circuit, between the 2 points X and Y, the resistance would equal RA in parallel with the quantities RB in series with RC, and the 2 points XZ, the resistance would equal RB in parallel with the quantity RA plus RC, and the 2 points ZY, the resistance would equal RC in parallel with the quantity RB plus RA. In the Y configuration, the resistance between the same 2 points XY, the resistance would be RD plus RE. Between the 2 points XZ, the resistance would equal RD plus RF, and between Z and Y, the resistance would equal RE plus RF. Assuming that we convert the delta to the Y equivalent, then RXZ will equal RA in parallel with RB plus RC, RXZ would equal RB in parallel with the quantity RA plus RC, and RZY would equal the quantity RC in parallel with RB plus RA. Note that we have three equations now and three unknowns. RD, RE, and RF. We know RA, RB, and RC. Thus we can solve these three equations using a term of elimination process. If we subtract equation 3 from equation 1, we eliminate the second resistance, RE, and arrive at the difference between the first and the third unknown resistances, RD minus RF. Now, let's bring down equation 2 and add it to the results we have from the previous subtraction, and we get 2RD is equal to RA in parallel with the quantity RB plus RC, plus RB in parallel with the quantity RA plus RC, minus RC in parallel with RB plus RA. Let's expand the three parallel terms on the right-hand side of the equation. That would give us 2RD is equal to the sum of three fractions you see here, all over the same denominator, RA plus RB plus RC. As you can plainly see, we have a common denominator, the quantity RA plus RB plus RC. In the numerator, we have the terms RB, RC canceling out because one is subtracted from the other, and the terms RA, RC canceling out because of the same reason. We have one subtracting the other. That would be leaving us with 2RD equal to 2RA/RB divided by the quantity RA plus RB plus RC, or RD is equal to RA/RB divided by RA plus RB plus RC. We could go through the similar process and obtain RE, which is going to be equal to RA/RC divided by RA plus RB plus RC, and RF is going to be equal to RB/RC divided by RA plus RB plus RC. This allows us to convert a delta to a Y configuration. This video is part of my electrical technical information series. In this series, I will be covering essential topics to help you understand electrical systems. These topics are small excerpts from my courses located in my stand store, which you can access by going to this web address. By going to this web address, you'll be asked for your name and email address. By submitting your email address, it will not be shared with anyone else or any other company, and it will allow me to periodically let you know when updates occur in these lessons. Here is just a sample of some of the reviews that I've received for my courses. As I said, this is just a sampling, and I will apologize in advance for the brief look at them, but you get the idea that the courses have been highly rated, most of them 4.5 to 5.0 out of 5 points.